Hi, 8th grade. So in lesson 6, we learned about scatter plots. Today we're going to learn about patterns in scatter plots. We're going to look at scatter plots a little more with a certain eye to see kind of what they're telling us. So, few things. When you look at a scatter plot, you should ask yourself the following questions, and yes, they should be in this order. So the first thing that you need to ask yourself about the scatter plot, does it look like there is a relationship between the two variables used in the scatter plot? What that really is asking is there a pattern? So luckily you're going to have two options. Either there is going to be a pattern or there isn't. There is a pattern, then there is a relationship. If the plots are in random, then there's no relationship. So only if there is a pattern, then do you need to ask yourself the second question. If there is no pattern, you do not ask yourself the second question. Notice the second question starts with, is there a relationship? So if there is a relationship, you need to ask yourself, does it appear to be linear? Remember, if it's linear, it makes a straight line. Again, it's either going to look like a straight line or it isn't. So you have to think, would the pattern be well described by a line? Could you actually draw a line through the points, and is that where the points in the direction that they're going? Or what if it's in shape of a curve? Then it's nonlinear. We've talked about nonlinear functions before. It may or may not be in the shape of a line. So there's another option here. It may be no, that it doesn't look like it's going in shape of a line and it's not a curve. If and only if the pattern can be described by a line, you can go ahead and ask the third question. If it appears to be linear, again, it doesn't say nonlinear, it doesn't say if it doesn't look to be linear, if it's linear. If it's linear, then you need to ask yourself, is the relationship a positive linear relationship or a negative linear relationship? Now you got to ask yourself, after all the stuff we've done with lines, what do you think it means to be a positive linear relationship? And what do you think it means to be a negative linear relationship? Okay, well, to be a positive linear relationship is a positive slope. It's going up. So it would look like a line like this. Let me draw. There's an x and y axis, and my line is going up. Notice, as my x value is increasing, my y value is also increased. As I'm moving from left to right, my x values have to increase, and my y values are increasing because my line is going up. So the opposite, if it's a negative relationship, it's a negative slope, so the line's going down. So you're going to have a line like this. Here's my axis, here's my line. Notice, as I move from left to right, on my x-axis, my x is still increasing. But as you go from left to right, your y values are decreasing. So notice how it's in a negative relationship, as one goes up, the other one goes down, compared to a positive relationship where they both go up. So now take a look underneath that table. We're going to talk about different types of linear relationships. The first one is a strong linear relationship, and the opposite is a weak linear relationship. Notice that when there is a strong linear relationship, it clearly resembles a linear pattern or a straight line. Notice in my graph how closely those points look like a straight line. So the main keyword is it clearly resembles a linear relationship. For a weak linear relationship, the scatter plots that are linear, but they're not as close to a line. So notice in my graph, yes, it's positive, it's increasing from left to right. But notice how if I draw a line, the points aren't as close to my line. There's a lot more space in between them. That's why the second one is a weak linear relationship compared to the first one. If I draw a line, look at how spot on those points are and how close they are to my line. Two important terms that you're going to notice when we talk about scatter plots. They're going to kind of be the keys to the puzzle, and they're going to give you some interesting information. The first term that we're going to talk about is outliers. It's an unusual point in the scatter plot that does not seem to fit the general pattern. Outlier almost looks like outcast. If you look at the graph above, notice these cluster of points. In this point all by itself, it doesn't fit the pattern. Another term we're going to talk about is clusters. It's points in a scatter plot that form a single cloud of points. There may be two or more in one scatter plot. So notice in this scatter plot how there's a cluster of points here and a cluster of points here. These little outliers and clusters are just going to tell you some important information about the scatter plot. Okay, so now that you've learned a little bit more about scatter plots, you're kind of probably wondering, well, what type of questions am I going to be asked? So take a look. This is an example of something you may be asked in regards to scatter plots. So below is a scatter plot of data on weight in pounds and fuel efficiency in miles per gallon for 13 cars. Yes, you did this question already. Using the questions at the beginning of this lesson as a guide, so you're going to have to flip back to that front page. Write a few sentences describing any possible relationship between X and Y. First thing, I'm going to look at my graph. Notice it doesn't have X and Y labeled, so I'm just going to label them for them really quick. The first question is it a pattern? If I look, do my points appear to be going in some sort of pattern? Yes. The second question is it linear? Does it look like it can be described by a line? Yes. The last question is what shape? Is it positive or negative? So I'm going to put positive or negative. For this specific example, it looks like it's going downwards. From left to right, my points are going down. So I'm going to put negative. So now watch how I write this sentence, a few sentences to describe the relationship. Okay, so go ahead and use this as your model. So the sentence that I wrote, I started out and I said there appears to be a negative. Notice how I said the shape. I included the last question. A negative linear, it's in shape of a line, and there is a relationship between, notice how I explained the y-axis and the x-axis. So again, there appears to be a negative linear relationship between fuel efficiency and weight. That was one sentence I wrote. Since there is a relationship, that's why I wrote this specific sentence. So, the cars with greater weight, as I increase weight, the cars with greater weight, notice how I use the word tend to have lower fuel efficiency. So as I move from left to right, the fuel efficiency goes down.